Assalamualaikum and hello to all. Today we are going to study chapter 7, molecular shape. Okay, so at the end of the lesson, you should be able to explain what is BSEPR. And draw basic molecular shape. There are 5 of it. And predict and explain the shape of the molecule and bond angle in a given species. So BSEPR is actually valence shell electron pair repulsion. So it means electron pair in valence shell will repel each other. Okay, so electron pairs around the central atom, okay, will repel one another and arrange as far apart as possible from each other to minimize the electron pair repulsion around the central atom. Okay, what it means that if you have electron pair, they will try to repel each other in the valence shell of the central atom. And for the electron pair, there are two things, lone pair and bonding pair. So what about the strength? Okay, so you can see here lone pair will repel the lone pair the strongest. Okay, lone pair will repel the strongest. This one will repel the strongest. Why is it repel the strongest? It is said that lone pair is closer to the nucleus. Therefore, they can repel much stronger. And then lone pair can also repel with bonding pair. Okay, lone pair can also repel with bonding pair. And bonding pair can also repel with another bonding pair, but it is the weakest if we refer to the repulsion side. Yeah. Okay, so what are the best shape that you need to understand? There are 5 shapes, okay, and we can represent the A as the central atom, okay, A as the central atom, and B as the terminal atom. Okay, so let's see the first one, linear. So as you can see here, linear, the bond angle is 180 degree, and central atom earlier we say we can determine this one as A. And this is the terminal atom. Anything that is not central atom is terminal. So here you can see that there is one central atom A and two terminal atom B. So you can write this down in short form to represent the molecule that is AB2. Is there any lone pair? No lone pair. Okay, so because there is no lone pair, this is just AB2. If there is lone pair, it will be AB3E1 or something like that. But there is no lone pair here. So AB2. So AB2, if you have the structure like this, maybe BeCl2. Okay, so this is A, this is B, and BeCl2. The shape will be this one, linear. So you can determine the shape of this thing is linear. Okay, next one, trigonal planar. Okay, so the central atom is A, the terminal atom is B, so there are 3 terminal atom and 1 central atom, so AB3. So AB3, the bond angle is 120 degree. So for example, this one, it can be BF3. Okay, BF3. B is the central atom and F3 is the terminal atom. If I draw, the structure will be like this. B, F, F, F. Okay, if I draw in Lewis dot structure, means that I need to put down the dot symbol. Okay, so BF3 is actually 120 degree the bond angle, and the shape is actually this one, trigonal planar. Okay, so if you are given a certain species or a certain molecule, you need to determine what is the AB for it. Is it AB3? Is it AB2? Is it AB4? And from there, you can determine the shape of the structure. Okay, tetrahedral, the same thing, the same process. How many A? How many B? So always we are looking at one central atom only. So this one is AB4. Okay, so if it is AB4, automatically the bond angle is 109.5. Why is it 109.5? Because this is the bonding pair. Okay, everything here is bonding pair. Okay, bonding pair. Based on VSEPR theory, bonding pair repel bonding pair equally because everything here is bonding pair. There is no lone pair. Okay, so AB4. The example for molecule for this one is CH4. Okay, so if I draw, so it will be like this, CH4. Okay, so the structure is like this. Actually, you need to see this in 3D. If I connect the dot here, it looks like this. So you need to look this in 3D. This is not flat. This is in 3D. The same thing for this one. If I connect everything here, it is 3D. So you need to be able to see this in 3D. So what is the shape for this one? Tetrahedron. Okay, next one, trigonal bipyramidal. Okay, trigonal bipyramidal, the same thing. A, B, 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 B. Okay, so this one is AB5. So AB5, for example, maybe you can have PCL5. Okay, example here, PCL5. So PCL5 is actually trigonal bipyramidal. Okay, this is the same thing. You need to look this in 3D. So this is actually on the same plane. Okay, this is on the same plane, same plane. But this is 3D. Okay, that one is 3D. So as you can see from the name bipyramidal means there are two pyramids. This is one pyramid at the top and one more pyramid is at the bottom here. Okay, so you need to be able to see this in 3D. This is 3D, not flat structure. So PCL5, if I draw ECL, sorry, CL, 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 CL. And you can see that this is 120-degree angle, but this one is actually 90. Okay, so that is trigonal bipyramidal. And the last one that you are going to study is octahedral. So AB6, 1, 2, 3, 4, 5, 6. Okay, 6. So this is AB6 example. Let's say I have SF6. So SF6 is AB6. So SF, oh, sorry, F, 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 F. Okay, the same thing. This one, you need to be able to look in 3D. So this is on the same plane, but this one is like this. So it is 3D. So you need to be able to see this in 3D. Okay, so this is octahedral. So SF6 is octahedral. Even though there are two pyramids, this is not trigonal bipyramidal because the base here is not pyramid. It's not square. Sorry, it's not trigonal. This one is actually square. But this one is not square bipyramidal. It is octahedral. Octahedral actually refers to four face that it have. Okay, for example, okay, this one is one face. Face, FACE. Yeah, 1, 2, 3, 4. Okay, and four at the bottom and also four at the top. Okay, so four face here. Okay, four face. Okay, so that is octahedral. So after you already know the shape, you need to be able to determine the shape based on the species given. Okay, so let's try this one. So determine the molecular shape of this structure. Okay, the first thing that you need to do, you need to draw the Lewis structure for all of this. That is already learned in previous lesson. So let's just draw the structure. Okay, AlCl3. So AlCl3 means that this is actually AB3. Okay, AB3. So if you draw Al, Cl, Cl, Cl. So this one, AB3, if you refer back to the slide, it means that this is trigonal planar. Okay, from the structure that you draw, or by knowing what is the AB, AB2, AB3, you can determine the shape already. Trigonal planar. And CH4 is AB4, right? AB4. Even though you already know AB4 is tetrahedral, in exam, you still need to draw. If the question asks you to draw. So do not draw AB3, draw CH4. Okay, CH4. CH4. Okay, so this one is tetrahedral. PCl5, AB5. So draw, sorry, P, CL, 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 CL. So this one is trigonal bipyramidal. Okay. Do you need to memorize all these things? Yes. Of course, you need to memorize. In exam, it will not be given. SF6, ABC. And ABC is octahedral. Octahedral. So this one is octahedral. So you need to be able to determine it is as octahedral because the structure is like this. There are 8 faces, and also you can determine it is octahedral because it is ABC. And the last one is BECL2. So this one is AB2. So AB2, BECL, CL. Do not forget to write down the bond angle. I already forget for this one. So this one is actually 90. This one is 120. This one is 120. Okay, sorry. This one is 90. This is 120 and 90. This one is 109.5. This one is 120. Okay, so this one is linear. Okay, so you determine the molecular shape for this structure. Okay, so that is all. So good luck to you and bye.